Amines play an important role in our survival of life. Amines have a wide stretch of application in many fields related to our daily lives. Hi, my name is Sahibjot Singh. If you're worried about passing an Amines quiz, I'm the man for you. I will help you pass that quiz, and I'll be teaching you all the wonders of Amines, how they're made, how they're used in our daily life, and how to name them using IUPAC rules. And I'll also teach you other side things such as priorities and physical properties. That's me, handsome. Aren't I a cutie? Throughout this video, I'll be teaching you numerous amount of things about amines, how amines affect human health, pharmaceutical uses, recreational uses, how to name and draw amines using IUPAC rules, general form, priority, suffix, physical properties of amines, example of naming, example of drawing, 3 different examples for each, reaction, how many a reaction occurs, and synthesis, step by step, chemical formula, and consolidation for you to try on your own to see if you could improve. Amines play a part in human health by creating amino acids that build blocks of protein in living beings, control the speed of the brain, and also waking up cycle of the brain. Other amino acids help control the feeling of hunger and happiness in the brain. Medicine based on amines such as morphine and Dermanol are commonly used as analgesics, medicine that relieve pain. Amines such as Novocaine are used commonly as anesthetics, used by doctors to numb down the pain. Some recreational use of amines are pest control, water purification, development of crop protection and chemicals, and also used in many products of care such as toothpaste. Some amines such as methamphetamine are popular recreational drugs. Based on the hit series Breaking Bad, the main character, Heisenberg, say my name. Sorry, got into it. Back to the lesson. Next up, how to name amines. Name and draw. Highlight the parent chain. Identify how long the chain is, such as heptohexane. Identify the ball, alkene, alkane. Identify the location of the amine. Find any side chain. Find any other functional group such as bromo, ido, and write in alphabetical order once you're done. There are 3 different types of amines, primary, secondary, and tertiary. Primary has 1 molecule attached to it with 2 hydrogens. Secondary has 2 molecules attached to it with 1 hydrogen, while tertiary has 3 molecules attached to it with no hydrogens. Priorities are important, so make sure when you number it, it's according to the list above. The suffix for amine is amine. When there's 2 groups of amines, it's diamine. Let's talk about physical properties. The first physical property we talk about are the primary amines. They have a high boiling point and melting point. They have hydrogen bonding and dipole-dipole forces. They have the strongest forces. Secondary amines. They have a lower boiling point and a melting point than primary amines because they have 1 less H. They still have hydrogen bonding and dipole forces. Tertiary amines. They have the least boiling point and the least melting point, but they have no hydrogen bonding, just dipole-dipole forces, since it has no H. Let's get to our first example. This example contains an amine and a bromo. We're gonna number it first, and we notice there are 5 carbons. We also notice there is a bromine at 3. We're gonna write 3 bromo. We also notice that there are 5 carbons, so which means it's pentane. You're gonna cancel out the E because when we add the amine, which is located at 2, we're gonna name it 2-amine. Now we're gonna label everything in alphabetical order. It's 3 bromo, 2 pentane amine, 3 bromo, 2 pentamine. Next example is an amine with a side chain and a parent chain. First we're going to label which one is a parent chain, which is the longest, which is that one. Now, we're also gonna label how many carbons there are. We're gonna count 1, 2, 3, 4, 5, 6. 6 carbons. So that means there is a hexane. Now, we're gonna label the side chain and name it. We notice it's a methyl. So we're gonna write N-methyl because it's connected to the N. Now, we notice that the amine is at 1, so it's going to be named 1-amine. Now, to put it all together, we're going to label it in alphabetical order. So it's going to be called N-methyl 1-hexanamine. This one is an easy one, folks. It has no side chain connected to it. It's just a long parent chain. We see there are 5 carbons, 1, 2, 3, 4, 5, which means it's pentane. We're going to cancel out the E, and we notice at 2, there's an amine. So it's 2-amine. Now we're going to put it all together. 2-pentamine. Okay, folks, I know that we had fun naming. Let's get on to drawing. So we're going to make butane. You notice butane is in this, so that means there are going to be 4 carbons. This is going to be our parent chain with 4 carbons. Let's count 1, 2, 3, 4. We got that requirement right. Now we notice that there's going to be an amine at 1. So with 2 hydrogens, because only one thing is connected to it with 2 H's. Now we see it's connected to the 1 and we meet the requirement. Next problem is N-methyl cyclohexamine. We notice that there is a cyclohexane. That means it's a hexagon with 6 sides. So we're going to draw a hexagon with 6 sides. That would mean there are 6 carbons in total. Let's get counting. 1, 2, 3, 4, 5, 6. Now we notice that the amine is going to be at 1. We also notice that attached to the N it's going to be a methyl group because there's only one H connected to the N. So we're going to draw that and see there is 1 methyl attached to that N. We notice that the hexane is our parent chain and this is our side chain, the N-methyl. Next up is N-methyl 3-pentamine. We're going to draw a carbon chain with 5 carbons. 1, 2, 3, 4, 5. It has 5 carbons, so it's a pentane. Now we notice at 3, there's going to be an amine. We're going to name it NH. The reason we write an NH and not an NH2 is because there's an N-methyl. When it's an N-methyl, that means only one H is going to be connected to the N. Now we're going to label the parent chain, and now we're going to label the side chain. The side chain is N-methyl, and the pentane is the parent chain. Amine, there's only one reaction that occurs, and that's called substitution reaction, where a hydrogen atom or a functional group is replaced by a different functional group. In this case, it's going to be ammonium. There will be 2 compounds that react to form 2 different products. Let's get started. Amine could only be formed through a substitution reaction. Here we see true bromobutamine with ammonia. Here we're going to see the ammonia kick out the Br in the parent chain. It's going to give away a hydrogen to Br and have an NH2. You see it's a butamine with NH2 on the 2. So it's going to be called 2-butamine with hydrobromic acid. That's when the hydrogen went to the Br. This is the inorganic product. Strap yourselves in. Now we're talking about the synthesis of an amine. Here we have an example, N-butyl 1-pentamine. This is how the final product looks like. There's a but on the left and there's going to be a pentane on the right. There's a 5 carbon chain on the right and then a 4 carbon chain on the left. The 4-carbon chain in this case is the shortest one, so it's going to be our side chain. Let's just get started on our side chain first. Now we're going to create this side chain using 1-chlorobutane. Now we're going to react it with ammonia, which is NH3. We're going to take that NH3 and one of the hydrogen is going to react with the chlorine, meaning the NH2 is going to bump out the chlorine in this situation. The catalyst is UV light. We don't care about the inorganic product, we only care about the organic product. In this case, it's going to form 1-butamine because the NH2 bumped out the chlorine. Now we're going to take this side chain to create another main chain that was formed in our final product. We're going to take that 1-butamine and react it with 1-bromopentane. The bromo that is connected to the 1-carbon chain, it's going to be bumped out by the N. That means there's only going to be 1 H connected to it with 5 carbons on the other side and 4 carbons on the other side. The 5-carbon chain is our main chain, as you can see in the final product. And there's a butyl which has 4 carbons as the side chain. See, we got our final product. Clap it up, guys. That was a long stride. Now, let's talk about ways of representing organic products. The example we're going to use is N-methyl 1-hexane. First, we're going to draw a line diagram. A line diagram can be used to represent an organic product in this case. So first, we're going to find the parent chain, which is hexane. So we got to draw 6 carbons, 1, 2, 3, 4, 5 in a line connected. 1, 2, 3, 4, 5, 6. Now we see at 1 there's a amine, so we're going to connect the NH to it. The reason there's only 1 hydrogen is because there's a methyl attached to it. Those tricky methyls, you know. So there's 1 methyl connected to it. As we know, the parent chain is 6 carbons, the side chain is 1 methyl, and we notice that we have met all the requirements that were asked of us in this case. Next up is a complete structural diagram. To draw this diagram, we're going to look at the example that was given, N-methyl 1-hexamine. We notice that there is 6 carbons attached to it. So we're going to draw those carbons, 1, 2, 3, 4, 5, 6, and we notice that there's also 1 methyl. So there's also 1 more carbon attached to the N. So that means there are 7 carbons in total. Now we're going to attach 1 H to as many H's to fill the gap in the H, so it has all the electrons that it needs to have a full vacant shell. We notice that the N has a lone pair. That means that all the shells are full. See, we have the parent chain with 6 carbons and the side chain with 1, which is N-methyl. We could use this information to draw our next diagram. In this case, it's the, drumrolls please, molecular formula. The molecular formula, with the information we had before, we could see there were 7 carbons, 17 hydrogens, and 1 nitrogen. We see that because the 1 extra carbon was given from the N-methyl and the 6 carbons that were given from the hexane. Now we're going to do the expanded formula. The expanded formula is pretty easy. It's just that without different sets of H's connected to it, we're going to label it all at once. So it's going to be CH3 with connected to the NH, connected to this connected to CH2, another CH2, another CH2, another CH2, and another CH2 connected to the last one, which is CH3. We see there's 6 carbons in the parent chain and one lone methyl group with 1 carbon attached to the N. Thank you for listening. Everything you need to learn about amines You're surely gonna pass this quiz after you do these couple of questions, I promise. After all the advice you have listened to me, use the tips and tricks that you have learned from this video to answer the following question. Name the two molecules, draw one of the molecules, and finish this reaction. Only needed the organic product. If you follow this video, it will surely make sure you get a name. Thank you for watching. Always, Heisenberg.